Hello Titans, this is Mr. Sturts. We're on the final section of Chapter 5, Section 5.7, which is Systems of Linear Inequalities. There is one vocab word I'd like you to write down in your student journals. So write down the systems of linear inequalities. All that is a set of two or more linear inequalities that have the same variables, that have x and y. And we're going to graph these. All right, first example here, we want to figure out if it's a solution. We've been doing this for a couple sections now. All we're going to do is plug in our x-coordinate, which is 3 for x, our y-coordinate, which is 5 for y, and see if they're true. They have to be true for both of them. So let's plug in 5 for y. 2 times 3 is 5 less than 2 times 3 is 6. Well, yeah, that's true, so that checks out. The second one, plug in 5 for y. Greater than or equal to 3 plus 1 is 5 greater than or equal to 4. That checks out. So yes, it is a solution. They both have to be true. All right, let's try B real quick. B, remember we have our x and our y. 0 is less than 2 times negative 2. Oops, negative 2. Get a little ahead of myself. 0 is less than negative 4. Is that true? No, 0 is actually greater than negative 4, so that doesn't work. So we don't even have to check the second one because we know they both have to be true. So we can assume right away that that is not a solution. Okay, if you get one that's not true, you don't even need to check the other one. We do not have a solution there. All right, our core concept for today, we're going to graph our inequalities again, just like last section, except now we have a system of linear inequalities, which means we have more than one. So we're going to have more than one graph. We're going to shade wherever those graphs overlap, wherever the shadings overlap, that is where our solution is going to be. All right, so we need to graph these two lines. First one, y is less than or equal to 3. We know since it's y is less than a number, we know it's going to be horizontal through the y-axis at a positive 3. And since it's or equal to, it's going to be a solid line through the point 3 on the y-axis. Less than, we know we shade below the line. Okay, so we're going to shade that below the line. We'll shade that in black there. Everything below the line. Now our second line here, y is greater than x plus 2. Okay, so let's go to 2. Maybe let's make this line red. Okay, let's go to 2 on our y-axis. Plot our y-intercept. Our slope is 1 over 1, so we're going to go up 1, right 1, up 1, right 1, up 1, right 1. We can see our line starting to form. This is a dotted line because it's not or equal to. So let's make our dotted line through those points. Now we need to shade again. Greater than. So we know greater than, we said we shade above the line, so we're going to shade everything above the line. Now, this is the new part for this section. Only where our shadings overlap is where our solution is. Okay, we see where there's black and red in here, in this little shaded area. This is our solution, nothing outside. Okay, just where our shadings overlap. Okay, let's try another one. We can't graph these right away. We need to get y by itself. We need it in slope-intercept form. So let's go ahead and move our 2x over on both of them. Subtract our 2x. Subtract our 2x. So what we have left is y is less than, let's write our negative 2x first, minus 1. Do the same thing on the second one. Subtract 2x to get y by itself. So y is going to be greater than negative 2x plus 3. Let's go ahead and graph these. Notice our slopes are the same. We know they're going to be parallel lines, but we need to see where the shadings are. So we still need to graph these. Negative 1 is our y-intercept. We're going to go down 2, right 1, because our slope is negative 2 over 1. Down 2, right 1, down 2, right 1. We know it's a dotted line because it's not or equal to. So let's go ahead and make our dotted line there. Goes on forever. Less than, so we're going to shade below the line, so we're going to shade over here. Now let's graph our other line. Let's make it red again so we can tell the difference. Our y-intercept is now 3, so we're going to go up 1, 2, 3, plot our point. Slope, down 2, right 1, down 2, right 1, down 2, right 1. Again, it's a dotted line. because it's not or equal to. Notice those lines never intersect, but what we're worried about in this section is the shadings, where those shadings overlap. It's greater than this time, so we need to shade over here. Now our question we ask ourselves, do those shadings overlap? Well, we see no, they're never going to overlap. Okay, those lines are parallel, they're never going to overlap, so our answer there is no solution. Okay, those shadings never overlap, so we're never going to have a solution. All right, now we're kind of thinking backwards here. We need to write the system of linear inequalities. They already gave us the graph. We need to write the inequalities themselves. Okay, so let's start with maybe this line right here, this horizontal line. We know it's horizontal, so we know it's going to be y is greater than or less than a number. Okay, now we see that that goes through -2 on the y-axis. Okay, that point is -2 there. Now we got to ask ourselves, did we shade above or below that line? Well, we see the shading is up here, so we know we shaded above that line. So when we shade above, we have a greater than. Okay, that's one inequality. We need the other one. Let's look at that dotted line. Okay, it's dotted. Oh, let's check that first one. It's a solid line, so we see that needs to be or equal to. Hopefully some of you caught that. It's a solid line, so it's greater than or equal to. All right, back to that dotted line. We need to first find, we know it's going to be y is greater than or less than some number, but let's find our y-intercept. Our y-intercept is right there at 0. Okay, so we know our y-intercept is going to be 0. Remember, we're trying to write these in the form y equals mx plus b. Okay, our y-intercept 0. Let's see, we shaded below that line. So if we shaded below the line, we know it's going to be less than. It's not or equal to because it's a dotted line. So we have less than. Now we need our slope. So if we started our y-intercept, let's try to find our slope. If we go up 1, right 1, we get to another point. Up 1, right 1, we get to another point. Up 1, right 1. So we know our slope is just 1 over 1, or simply 1. So we have 1x plus 0. Okay, so our system of inequalities, we have y is less than x plus 0, and we have y is greater than or equal to -2. If we were to graph those, we would get that graph on the right. Okay, let's try one more of those. We see the vertical line. Let's start with that one. We know vertical lines is x equals now. We shaded to the left of that vertical line, so we know it's less than. It's a solid line, so we know it's or equal to. And then it goes through the x-axis at 3. Okay, now let's look at our dotted line. We got to first find our y-intercept. Our y-intercept looks like it goes through at -1, so let's throw that over here. We shaded above that dotted line, so we know that's going to be greater than. It's not or equal to because it's a dotted line. Now we need our slope. So let's again go to that y-intercept and count. Okay, we need to go up 1. Let's go up 2. And then right 1, 2, 3. We get over to there. Our slope looks like it might be up 2, right 3. So our slope is going to be 2/3 x. So our system is right here. 2/3 x minus 1. And x is less than or equal to 3. All right, last problem here. We have a little application problem. We have at most 8 hours to spend at the mall and at the beach. Okay, let's say x is the mall, and let's say y is the beach. Okay, if we have x plus y. We have at most 8 hours, so that means we can't spend any more than 8. We need to spend less than, but we could still spend 8 hours there. Okay, that is that equation there. Now we need 2 other ones. Okay, we actually need 2 more equations here. So if we look at that next line there, you want to spend at least 2 hours at the mall. Okay, so we know at the mall, we need to spend at the very least 2 hours. So we need to spend more than or equal to 2 hours. Okay, that's at the mall. Now at the beach. Okay, we want to spend more than 4 hours at the beach. So we know that y, we need that to be greater than 4. Okay, we want to spend more than 4 hours at the beach. Okay, now let's finish up here. We need to graph these. Okay, let's start with our first one. We need to get y by itself, so let's subtract x. Okay, y is going to be less than or equal to -x plus 8. Okay, we go up to 8, 1, 2, 3, 4, 5, 6, 7, 8. Plot a point. Our slope, -1. So -1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. Okay, we have our straight line through those points. Now our second line, x is greater than or equal to 2. We know that's going to be a vertical line through 2. Okay, so we're going to do a solid line through 2 here. Notice we have 3 lines on this graph. We haven't done that before. Okay, let's do our last one. Y is greater than 4. We know that's a horizontal line through 1, 2, 3, 4. It's dotted because it's not or equal to. So we have this right here. Okay, that's our dotted line. That should be dotted there. Now we need to shade. Okay, we need to shade. That first one is less than our diagonal line. Okay, so let's go back to our diagonal line. We know that needs to be shaded below that line. So we're shading over here below our diagonal line. Our second line, our x equals, let's make that one blue. Okay, x is greater than or equal to 2. Okay, that's our vertical line. So greater than, we're going to shade to the right of that vertical line. Now this is getting a little messy, I know. Greater than 4, let's make it a different color. Let's do this is now our horizontal line, greater than. We're going to shade above that line. Okay, now what this mess all shows here. Look at where our shadings overlap. Okay, we have in this little tiny triangle here, all these shadings. Okay, what that means is that is our solution. Inside that triangle, that's our solution to our problem. All right, now that we're finished, go to your student journal, page 165. Do these 3 problems for tomorrow in class. We'll look them over. Sorry this video was a little longer. There's a lot of material to get into one. Thank you for being patient and watching, and we will see you tomorrow in class. Have a great rest of your night.